Magnetic forces on moving charges. The magnetic force on a moving charge is always perpendicular to the charge's velocity, v, and the magnetic field, b. It cannot change the speed of the moving charge, only its direction. Let's picture this. So let's picture a magnetic field entering into the page or the screen. So given by these symbols x. This x represents the magnetic field. Let's say you have a point charge with a charge of plus q, and it's traveling up in the up direction, and that's the velocity. Now, we said here that the magnetic force Fb is always perpendicular to the velocity and the magnetic field. Therefore, at this instant, the magnetic force would be in this direction. Now, so this force is going to be essentially pulling this magnetic field and changing its direction. Let's say at a later time, the force is now here and is moving in this direction. Well, again, the magnetic force is always perpendicular. So what happens is this charge will experience or will travel in uniform circular motion because of this magnetic force always being perpendicular to the velocity. Now, we can determine two important factors or two important measurements. We can determine the magnitude of Fb, and we can also determine the radius of its path, r, given in the next screen. So here are the two equations. The first equation is the magnitude of the magnetic force, and that's the charge times the velocity times the magnetic field times the angle that is made between the charge and the magnetic field. In addition, we can determine the radius of its path, and that's given by the mass times the velocity divided by the charge times the magnetic field. Magnetic force, again, is always in newtons. Force is always in newtons. And then there are basically no other new terms in this. The only term we need to know is theta, which is the angle between v and b, so the velocity and the actual magnetic field.